Okay.
So I can change the speed at which the light flashes. So this is C, 128 hertz. So the one that I just did was 880. This is 128. So if you were to compare the wavelength of a 128 hertz versus 880, which one's going to have the longer wavelength? The 880 or this one? Why?
Less frequency.
Yeah, so that's vibrating at like 880 vibrations per second. This is at 128. So if I do this, and this one you can actually kind of see it vibrating back and forth. So what you can do with the strobe light then, and you got to get over here where you can see this, is that if I hit it just right.
Whoa. Oh, it's moving.
Whoa.
Oh my god. It's like the Flash. You can see. Yeah.
So you can slow it down where it looks like it's
Oh, I see it.
standing still. So what's happening, and then you can make it change what it looks like it's going in one direction, and you can make it look like another direction.
Mr. Birkin, why does it do that?
Because your brain has like a memory. So what allows us to do this where it looks like it's going slow or even staying in place is that every time your brain gets an image, it freezes it in time and space for a split second. It isn't like a continuum. So when you do that, what your brain is doing, your brain is trying to merge together different images. And so that's why it looks like it's standing still, is because that flash of light is hitting it at the same position every time. And your brain is going, oh, I'm seeing it at the same position every time. So your brain doesn't see it as a continuum. So the reason that appears either like right there, it's staying pretty still, okay, is because that flash of light hits it in the same physical place every time. And your brain goes, oh, I see that at the same place every time. And your brain tells you that it's standing still. But in reality, what's it doing?
Moving.
It's moving. But your brain is seeing that flash, and your brain holds that memory, and your brain tries to stitch that together. Okay? So, all of this is, and that's why I said, so this is like the quintessential way to show that sound is a longitudinal wave. Because every time that tuning fork goes out, that's a compression. Every time it comes back in, that's a rarefaction. So when I hold this up beside my ear, what's that doing is that it's boom, going back and forth, compression, rarefaction, compression, rarefaction. And I hear that, and your brain goes, oh, that's a sound, that's a certain frequency. Because it's transmitting that sound through the eardrum, through that mechanism, through your auditory nerve to your brain, and your brain goes, ah, Burkham's talking about sound. Okay, got it? Good, grand. Okay, back we go.